सबका कुछ ना कुछ सीक्रेट होता है, तो आइए डिकोड करते हैं कि इस स्वीटनेस का सीक्रेट क्या है. हाय एवरीवन, आई वेलकम यू ऑल टू द अनदर ऑनलाइन लेक्चर. टुडे वी विल बी understanding about the glycosidic bond. Okay, so when we talk about glycosidic bond or the glycosidic linkage, it is a covalent bond, and we know that covalent bond will be formed by mutual sharing of electrons. Moreover, the glycosidic bond not only connects one carbohydrate sugar molecule to another sugar molecule, but it may also connect one sugar molecule to a non carbohydrate group. So, it is not always so that the glycosidic bond will be only in between two sugars. It can be between one sugar and another non carbohydrate group. Okay, so it is the simplest bond which is formed by the condensation reaction, or you can say that two molecules will be condensed and then there will be dehydration. Okay, so let us move on to the types of glycosidic bond. The glycosidic bond may be O linked and the glycosidic bond may be N linked. So when the glycosidic bond is O linked, it can be further of two types. One is the alpha linkage and another one is the beta linkage. So let us further explore the O linked glycosidic bond. Okay. So in the O linked glycosidic bonding, so we know that the bonding is formed when a hydroxyl group of one sugar molecule, which is, yes, of course, typically cyclic, because we know that the glucose in nature, it always remains in the cyclic form, whether in the boat conformation or in the chair conformation. Okay, so when the molecule, it is going to react with the anomeric carbon atom of the another, then the O glycosidic linkage will be formed, and this linkage is further of two types. One is alpha linkage and another one is the beta glycosidic linkage. So let us now understand that how we are going to discriminate that what the alpha linkage is and what the beta linkage is. So we've recently studied that when in the glucose molecule, see, this is the glucose molecule, H O H H O H H O H. So in this glucose molecule, if at the anomeric carbon atom, that is carbon atom number 1, the H lies above the plane, it is known as alpha glucose. Okay, so now we will be considering only the first sugar involved. If the, please listen carefully, if the first sugar involved has the alpha configuration, that means if in the first sugar which is being involved in the glycosidic linkage, if in the first sugar the H is above the plane and OH is below the plane, then the O glycosidic bond will be alpha type. Okay, but if the first sugar involved is in the beta configuration. What does beta configuration means? That in the structure of glucose, the OH lies above the plane and H lies below the plane, then the configuration is beta. Okay, so when the first sugar involved is beta, then we say that the bond formed will be beta glycosidic bond. Okay, it will be beta glycosidic bond. So here we see the classical example of glycosidic linkage. Here you can see this is alpha D glucose. All right, this is alpha D glucose, and the anomeric carbon atom, which is the first carbon atom, at the anomeric carbon atom, the H lies above the plane and OH lies below the plane. So if the bonding, when the glycosidic bonding will be formed and the first glucose or the first sugar involved is in alpha configuration, then the bond will be alpha. Here is alpha, and why this is alpha? This is the alpha because the first sugar that is being involved is in alpha configuration, and it is alpha 1,4 glycosidic linkage. So this is the structure of maltose. Here you can see it is a simple condensation reaction. Okay, and by condensing two molecules of glucose, one is the alpha conformation and another one is the beta conformation, but the first glucose is the alpha glucose, hence the bonding will be alpha 1,4 linkage. That is the catch. The catch is that if first sugar involved is in alpha configuration, the bonding will be alpha, and if the first sugar is in beta, the bonding will be beta. So let us see here. Okay. So now let us understand the beta glycosidic linkage. So when the first sugar involved in the glycosidic bond is in beta form. So here the first sugar involved is galactose. We already know that galactose and glucose are epimers of each other at carbon atom number 4. So here you can see carbon atom number 1, 2, 3, 4. If you see the structure of glucose at the fourth carbon atom, the H lies above the plane and OH lies below the plane. So similarly, at the fourth carbon atom in galactose, OH lies above the plane and H lies below the plane because galactose is epimer of glucose at carbon atom number 4. Yes. So this is the structure of galactose and it has beta configuration. Okay. And if the first sugar involved is in beta configuration, here is the beta configuration at the anomeric carbon atom. That means carbon atom number 1. The OH is above the plane and H is below the plane. And when these two molecules condense, water is being eliminated and the bond formed is beta 1,4 glycosidic linkage. So this is how we depict the beta linkage. So the catch is of only the first sugar involved. Okay. Now moving on to the another part, that the O glycosidic bond, it can be formed with a molecule other than sugar. Here you can see that this is the N-acetyl glucosamine. This is the structure of N-acetyl glucosamine and this is the amino acid serine. But this N-acetyl glucosamine is together linked by this molecule of serine by O linkage, and such kind of linkage is also known as glycosidic linkage. All right. Now moving on to the N-glycosidic bonds. So usually the N-linked glycosidic bonds, they are formed in the oligosaccharides. So when these join the anomeric carbon of a sugar to nitrogen atom in glycoproteins, and this is also found in the nucleotide. So here you can see at the anomeric carbon atom, this is the glycoprotein, this is asparagine, residue of that protein. Okay, so this is the anomeric carbon atom, and here you can see the linkage is joined by N. All right, so yes, the N-linked glycosidic bond also exist. Okay, so that's all for today. In case if you want a lecture on any other topic, please comment down. Stay tuned in. Thank you.